everybody. Today we're going to be going through the last couple of questions from the last couple of pages from the Year 9 Numeracy Calculator Allowed NAPLAN test from 2016. I've been asked to go through the last couple of questions, I think the last two, but I'll go through the ones that I missed out on in an earlier video. If you've got any questions, please leave it in the comments below. I'll try and get back to you as soon as possible. So, question 28, Mike puts $1,000 into a simple interest account for a year, doesn't take any money out, ends up with 1,050. What is the annual percentage interest rate? Well, all we need to do is divide the final number by the smaller one, and that will get us a decimal answer of the difference between them. So 1,050 divided by 1,000. Oops. And that's 1.05. And then if you multiply that by 100, that'll give you the percentage difference. And obviously 100% is if there was exactly the same amount. If there was 1,000 that we started with, 1,050 that we ended with. So we take 100 from that, and that shows you what the percentage difference is. It's 5%. 5% of 1,000 is 50, and we increased an extra $50 from 1,000 to 1,050. So that's that one right there. When it comes down to question 29, Seth draws a target as shown, not to scale. What is the area of the entire target? Add your answer to the nearest square centimetre. So for this one, it's saying what is the area of the entire target. So obviously this whole circle, as you probably know, pi r squared will get you the area. So for us to figure out pi r squared, we need either an r, a radius, or a d, diameter, to be able to halve it and get the radius, or to use a very similar formula. But we'll just use pi r squared. We've got 2.5 centimeters from the bullseye to the end of the dark area, another 2.5 for another dark area, another 2.5 for another dark area. The whites are also 2.5. So if we just count them all up, 1, 2, 3, 4, 5, there's 5 lots of 2.5 centimeters. 5 times 2.5 centimeters, and that will get us 12.5. I'll delete everything else. I'll try to. That's okay. 12.5 is our radius, so we just need to square that. That's our r squared, and then multiply that by pi, and I'll just go 3.14 as a rough. And it gets me 490. If I want it absolutely exact, I'll go the exact. So I'll get my 12.5 number here. 12.5 times 12.5, 156.25. 156.25 times pi. That gets me 490.87. So that will be the answer that we want. To the nearest centimetre, we have to round that up to 491. So 491 would be the answer to that. Pi r squared is the formula that we use. I might actually put that down on this, that way we can see it a bit clearer. So we're using the formula pi r squared to get area of a circle. Area of a circle. The r we figured out was 5 lots of 2.5, which equals 12.5, when r squared was 12.5 times 12.5, which was 156.25, and then pi r squared, of course, is the 156.25, which is r squared, times by our pi, and that's got us, what was it, 490.86 I believe it was, which which of course rounds up to 491. And that will be square centimeters, square centimeters. So it can either go SQ, cm, or centimeters squared. Either or. They mean the same thing. Now that we've cleared the whiteboard, we can have a look at the last couple of questions. Question 30. The box below contains pieces of chocolate, 8.25 high, 10 centimeters is our half of the width of the base, 21 centimeter depth, 9.6 centimeter diagonal, and then we've got similarly triangular prism shaped, I'll call it Toblerone chocolate, that is going to fit in the box. And the question is, what is the maximum number of pieces that can fit inside the box? So first thing we look at is how high can we stack them. We've got 8 centimeters is how high the chocolate is. 2 lots of 8 is 16. This is much less than 16, so we can't stack them even too high. What about width? 10 centimeters of width, and I've made a slight mistake. 10 centimeters is the total width, not the half. 10 centimeters is the total width of this triangular prism of the box. The chocolate is 9.9. We definitely cannot fit too wide. So we can't go fit too high or too wide. The only thing we've really got is depth. And because the depth here is 21 centimeters and this one we don't know, we need to try to figure out how many can we stack up against each other to be able to fit in this triangular prism. So first we need to see how we figure that out. That is our unknown, the depth, but we do have the total volume, 75 centimeters cubed. That is the total volume of this triangular prism. Now hopefully we remember that for circles it is pi r squared to figure out the area, but then for a cylinder it equals pi r squared multiplied by height, so how long it is from there to there. Now it's exactly the same principle with triangles, where a triangle will be half base times height, and then if you have a triangular prism, it will be half base times height to get the triangular face times by the length of the triangular prism. So we're going to end up using that formula to solve it, given that we know that the total is 75 centimeters cubed. So I'll rub that out the board. So half base times height times length equals 75 centimeters cubed, the area of the triangular prism. Now we know that the base is 9.9, so we need to half 9.9. 9.9 divided by 2. So there's our half base. So our half base is 4.95. And our height is 8, and our length, so the depth of the triangular prism, we don't know yet, so we'll just leave that as L, and that equals 75 centimeters cubed. We'll put in the units later. So obviously we just need to do a bit of maths to get the L by itself, and because everything is multiplied together, all we just need to do is divide. So when we do 75 times divided by 8, it will get rid of this 8. So we'll do that first. So we've just got 4.95 times L equals 75 on 8, which we'll use our trusty calculator to figure that out. 75 divided by 8, 9.375. Then we're going to do the same thing again, but divide by 4.95. So L equals 9.375 divided by 4.95. Hopefully we remember that for fractions, numerator divide by denominator. So that's just another way of using a divide sign, of dividing one number by another. So if we do this as well in the calculator, if we divide that by 4.95, it gets us about 1.9. We'll call it 1.8. L equals 1.89. Now that means that we can fit, that means that the length, is 1.89 centimeters. So that's how long this is, or how deep this triangular prism is. So remember, we're going to compare 1.89 though to the box, which has 21. Because remember, we had already figured out that we can't stack them too high, we can't stack them too wide. We can only really go by the depth. And the depth is 1.89. Comparing that to 21, we just have to divide the 21 by 1.89 to see how many 1.89 centimeter triangular prisms will fit in the 21 centimeter box. So 21 divided by 1.89, because 1.89 is close to 2, you should probably expect to see a number a little bit greater than 10, and we get 11.1 recurring. But that 0.1 recurring doesn't matter that much. We just need to get how many whole triangular prisms can fit, and hence we get the number 11. So that's the answer for question 30. Let me rub out the board. Okay, and so we move to the next question. Question 31. What is the value of x if 3 halves of x plus 4 take 2x? 3 halves of x plus 4 equals 2x minus 1. Well, we're just going to write this out and solve it. So it's all about isolating the x's. So we've got 3.5 x plus 4 equals 2x minus 1. So we just need to get x by itself on one side, and then we'll have numbers on the other side, and that'll be able to figure it out. Hopefully we know that 3.5 x's means 1.5. So we'll probably be able to double that and make that nice and easy next time, or later on in this equation. So we'll get to that. First off, what I'll do, I always like to get rid of negatives. So we'll get rid of that minus 1 by plussing 1 to both sides. Plus 1 both sides. So that will end up making 3.5 x plus 5, because we've got 4 plus 1. And that will just equal 2x. Now I'm going to do something a little bit interesting, which will be to multiply both sides by 2, because I want to get rid of the fraction of 3 divided by 2. So if I multiply 3 divided by 2, we will get rid of that denominator. Anytime you multiply something with a denominator by that same number, that means we stop dividing by that number. Because if you, let's say if you have $10, if you divide by 2 and then multiply by 2, you still have $10, because you've done the same thing. They're just in equal magnitude but in opposite directions. Just like giving somebody $2 and then they give you $2. You still have the same amount of money. So that's what's happening here. We doubled the 3 over 2x to just make 3x. We've doubled our 5 to make 10. And we double the other side as well to make that 4x. Now I'm just going to take 3x from both sides. That way we'll just get a number on one side, and then we'll have a quantity of x on the other. So if I get rid of 3x's, we will only have 10. If I get rid of 3x's on this side, we'll have 4 take 3x, which is 1x, which we just call x. And then, as a result of this, we are left with 10 equals x, or x equals 10. And then we can put that into the original equation to see if that is the reality. Now, we established that 3 halves equals 1.5. We figured that out at the start. It's 3 halves, 1 whole and 0.5, which is a half. Okay? 3 halves equals 1.5. So that means that in this original equation, if I did 1.5 times 10, that equals 15, plus our 4 equals 19. So that's our left hand side. When it comes to our right hand side, we've got 2x, so 2 times 10, which of course is 20, and it says minus 1 afterwards, which equals 19. 19 equals 19. Both sides add up. So yes, x equals 10 is the correct answer. So what is the value of x? Value of x is 10. Let me rub out the board. Last question here. A design is made using twice as many large beads as small beads. The mass of each large bead is 120. The mass of each small bead is 80. The total mass of all beads is 32 grams. Well, this is important because the other quantities were in milligrams, which hopefully we know, just like millimeters to meters. The milli part means thousandth. Sorry, got to pronounce that properly. So 1,000 milligrams will make 1 gram, just like 1,000 millimeters make 1 meter. So then it says how many beads are used in total to make the design. So we'll use L and S as important numbers here. So it says that there is twice as many L as small, twice as many large as small. So twice as many large as small. So I've got to make sure that the number I have in front of L will be twice as many as what we end up having with S. Could be 2 to 4, 3 to 6, anything. But it has to be twice as many. It says 120. So L's weigh 120. And we've got to end up equaling 32,000. 32,000. So to end up solving this, now the way I'm going to do this might seem a little bit peculiar, but please ask questions if you want a little bit more detail with this. So because it's saying that we've got to use twice as many large beads as small beads, that obviously gives us very important information. Okay, and in combination with the different masses between the beads, that obviously is super helpful also. So because the large bead weighs 120 while the small weighs 80, this is actually a 50% difference between the two, and this is done by doing 120 divided by 80. It gives you 1.5, which your calculator can confirm, but we will use that calculator to confirm. 120 divided by 80 equals 1.5. So it's 1.5 times as much mass. Now, so we'll use that number for a start. 1.5. There's 1.5 times more mass. That's the mass difference between the two. But that's comparing one large bead compared to one small bead. But we got told we're going to have twice as many large as small, which means the mass of the large is going to be, of all of our large beads compared to all of our small beads, there's twice as many, and each one weighs 1.5 times as much. We have to multiply those two numbers together, and that will give us the number 3. And that means that there's 3 times as much. The mass of the large beads is 3 times as much as the mass of the small beads. Now, there's a very simple fraction that can figure that out, or even if you wrote it as a ratio, it's 3 to 1. 3 parts are large beads, 1 part is small beads. As a fraction, that obviously means 3/4 are large beads and 1/4 are small beads. So because we've already got the total mass, we can now figure everything out rather quickly. The total mass is 32 grams, which when going into milligrams we've got to multiply that by 1,000. So it's 32,000 grams is the total. If 3/4 of that is large beads, then we just need to do 32,000 multiplied by 3/4. $32,000 multiplied by 3 divided by 4. And that gets us 3/4 of 32,000, and that equals 24,000. And the remaining 8,000, which we can tell by doing 32,000 times by 1/4, or 32,000 take 24,000, because you're taking 3/4 away, so we'll give you 1/4 left. That means 8,000 is going to be of small beads. 24,000 is of large. Obviously a very important thing now. We need to find out how many beads are used in total to make the design. So if 24,000 worth of large beads are being used, so we've got to do 24,000 divided by how much each one weighs, which is 120. So 24,000 divided by 120 equals 200. So there's 200 large beads, and we've got 8,000 worth of small, and they weigh 80 each. Hopefully we can figure out that that will mean that there's 100 of them just by looking at it with a different number of zeros. But of course you have a calculator, so you can double check. 8,000 divided by 80 of course equals 100. So we've got the numbers 200 and 100. That's the number of beads. And the question actually asks how many beads are used in total to make the design. It's 200 plus 100, which makes a total of 300. So the maths all adds up, and it also agrees with the initial thing that it asked, which it was asking a design is made using twice as many large beads as small beads. So there's 200 and there's 100, twice as many. What I want to do, even though this is our answer, I want to actually now do this question but the other way around, where it's with twice as many small compared to large. That way you can get a better understanding of what maths we're applying to figure this out. So I'll just rub out some details here. Now if we were supposed to have twice as many small as large, the difference between the two is still 1.5. The larges weigh 1.5 times as much as the smalls, but now instead of multiplying by 2, we will instead be dividing by 2, which, let's do a little bit wet. We'll just put that 1 point. So that'll be 1.5 divided by 2, and that will of course no longer be 3, but it will instead be 0.75, which your calculator can confirm. Now this would mean that 3/4 of the weight would be, actually scrap all that, that maths is actually going to be wrong. There's a problem with trying to do it that other way around. We'll go back to the way that it was originally, twice as many L's as smalls. There is something else that I noticed, which is another way, a fairly advanced way to end up figuring out the answer. If you have twice as many larges compared to smalls, if we have the most simple example of that, where we've got 2 larges, so 2 times 120 will make 240, and then you've got 1 small, which makes 80. If you add those two together, you get 320. we're trying to get 32,000 grams in total, and we're already been given 320. Right there, if you actually divide 32,000 divided by 320, that already tells you how many sets of each you need, and that obviously gives you 100. So that means that you needed 100 sets of 2 larges and 100 sets of 1 small, which obviously gives us 200 larges, 100 smalls, which is another way to make the answer. Whilst I was just thinking about my working out, I realised that if you reverse the larges and the smalls to make 2 smalls for every 1 large, that can't give you an exact answer, like a round number answer. And the reason for that is if you have 2 smalls, it's 2 times 80 will give you 160. We'll put 2s. 1 large gives you 120. If you add these two together, you get 280. 280 does not fit so nicely like 320 does into 32,000, and this is confirmed by calculator. 32,000 divided by 280. So in fact that will give you decimal answers, which means you'll be only getting parts of bead, fractions of beads, decimals of beads, not nice round numbers. But anyways, we have done the last couple of questions of that NAPLAN test. If you've got any further comments or want further explanation, please let me know and I'll try and do things a little bit nicer. I hope you found this helpful, and let me know if you need any more videos on anything. Thank you so much for your time.